Hello students, this video is to help you review for the Unit 8 unit exam on trigonometry. I'm going to do problem set review from all the lessons starting at lesson 4 and going through lesson 9. It's going to be a lot of lessons, so I'm going to go a little bit quicker than usual. Take a look at the lesson 4 problem set, pause the video, try these questions, and then check back to see if you're right. Alright, the first page should have been fairly straightforward. It's using the idea that cosine of b is equal to sine of a in a right triangle. So in this case, we know that cosine of b is equal to 5, sine a is equal to 5. We also know that the two acute angles in a right triangle are complementary to each other. They add to 90 degrees, which means sine of a equals cosine of b. That's a fact that we learned about during this lesson. We're looking for the value of x in this, and we're given these two values. I'm going to underline these values. These are angles. As soon as they're inside those parentheses, we know that they are angles. And the acute angles in a right triangle sum to 90 degrees. That's why I set it up like this. Same thing here, we underlined these two because these are angles, and the measures of these two angles add up to 90 degrees. They're complementary angles. Explaining why these two are equal to each other, well, we know that this and this are angles, just like before. We add them together to equal 90, and we get the equation 90 equals 90, which is always true, which means the two acute angles in a right triangle are complementary. They sum to 90 degrees. The question here asked, are both students' equations correct? Explain why. Well, let's see an explanation. So you could have shown their two setups and said that the two equations are correct because they're set up correctly. You could have also said that the sine of a is always equal to the cosine of b for a right triangle, and we know that a is 28. That was given to us. We were able, using math, to figure out that this angle was 62. Using the triangle sum theorem, 90 plus 28 subtracted from 180 is equal to 62. So we were able to use either of those two explanations. Moving on to the lesson 5 problem set, there were a lot of word problems here with pictures, and it involved drawing triangles twice. Try to do those problems, pause the video while you're doing that, and then come back to see if you did it right. Alright, for each of these problems, you were required to take a look at the diagram and then make two different triangles, set up two trig ratios, and then try to combine them in some way. The first one was fairly straightforward because all you had to do is identify the total height, which was h. We found that using tangent. Then we had to find the height of the cliff, which we found using tangent again. And then subtract the two to figure out just the height of the lighthouse, because it should make sense to you that the entire height of the lighthouse plus the cliff minus the height of the cliff is equal to the height of the lighthouse. For the second one, it required a little bit more algebra. We set up two trig ratios, and we had two unknowns. We had a t and we had an x, because we didn't know this distance from the base of the tower to the beginning of the guy wire. So what we had to do was take the two equations and set them equal to each other. 2.145x is equal to t, and also this nonsense equals t. So we put them together. The blue equation equals the red equation. We solved for x, and then we substituted that x back into one of the other equations to find the value of t. This is algebra stuff. This is systems of equations, but you should remember that because you passed algebra. Last but not least, we did the same thing here, but we had a special shortcut, which I'll show you in a moment. We set the two equations equal to each other, just like for question number 2, and we found x is equal to 40.9891. We know that x is equal to h, though, and the reason being is because this angle is 45. And if this angle is 45 in a right triangle, this angle also has to be 45, which means it's an isosceles triangle. X and h are the same measurement. We knew that also because x is equal to h in this equation. So we set them equal to each other over here, we solved, and then we substituted in the value of x to get the value of h. Take a look at the second page of that problem set, pause the video, try it, and come back to see if you're right. One thing that you should have gotten from all of these problems is that both of the triangles have to be drawn, both of the trig ratios have to be set up, and then in some way, both of the equations have to be combined together. In every one of these cases, we did the same thing. We made a triangle. Incidentally, this side is 2050. This side of the triangle is going to be 2000 because the tower is already 50 feet tall, so this vertical part is 2000. Anyway, all the triangles should have been set up like this. And in every single one of these cases, we use tangent because tangent is going to be our opposite over adjacent. That's going to be usually our horizontal divided by our vertical. And in most cases, we don't really care about the diagonal distance. That's not something that we are able to measure. For the last question, it looked like this. It was Again, it was very, very cookie cutter, very, very similar. You set up the two equations, you set them equal to each other for in some way, and then you solve. All right, that was the end of the problem set for lesson 5. Take a look at lesson 6. This is where we started talking about the law of sines. Pause the video, try to do these on your own, and then come back to see the answers. All right, lesson 6 problem set requires this angle to be found using triangle sum theorem, and then set up two different laws of sines, both using 14 over sine of 78.4, because we know the side 14 and we know the angle 78.4, and they're across from each other. They're opposites. We can do the same thing here for question number 2. We use the triangle sum theorem to find that measurement, which is 55 degrees here. Then we used two laws of sines, both using 13 over sine 86, because we know the 13 is the side, and we know that's opposite of the angle 86. Question number 3, it gave us the law of sines, and it asked whether it applied to a right triangle. So we set up the law of sines, sine A over A, sine B over B, sine 90 over C, because we know that 90 is here. That's this angle here. Once we put sine of 90 into our calculator, we got 1, which means sine of A over A is equal to 1 over C. When we cross multiply, we get sine of A equals A over C. So the sine of A is equal to A, which is the opposite, over C, which is the hypotenuse. Sounds like that works to me, opposite over hypotenuse. Then the sine of B over B equals 1 over C. Let's cross multiply. That gives us the sine of B, so B is this angle here. The sine of B is equal to B, which is the opposite, over C, which is the hypotenuse. How about that? Opposite over hypotenuse. Since the opposite over hypotenuse is the sine of both A and B, the law of sines does apply to a right triangle. And then question number 4. The first thing we had to do is use the law of sines. We used this angle, which is 80. We used this side, which is 9. We've used that to find out the measurement of side GK, which is, of course, 7. Then once we had this side, which is 7, we used that for this red triangle, this right triangle, and we used the sine of 50 and the cosine of 50, both using the hypotenuse to try to find the opposite, which is KJ, and the adjacent, which is JG. All right, we're done with this page, which means we can move on to page number 2. This was still from lesson 6. Pause the video, take a look, and see if you can figure it out, and then come back and check. All right, for both of these problems, question number 5 and question number 6, it did ask you to use the law of cosines. But at this time, I hadn't given you the law of cosines yet, but as I showed you here, you can easily use sine, cosine, and the Pythagorean theorem to do the same exact thing. In a few moments, I'm going to show you the next problem set, which uses the law of cosines. It's a little bit easier. Question number 6, as I said, we're using both sine, cosine, and the Pythagorean theorem. And here, for question number 7, I'm giving you a little sneak peek preview. Question number 7 could have been done using the method described above, but here I'm using this shortcut, which is called the law of cosines. And aren't you glad I showed you that? One thing that I wanted to point out to you with the law of cosines is that this piece that's on the right-hand side of the equation, which is just a string of numbers, this you could calculate individually. It requires several steps worth. However, you could also put it into your calculator. So all of this 44 squared, 26 squared, etc. This all went into the calculator here, and I got 2214.69, etc. And then I square rooted, I got 47.0605. Keep in mind that since I rounded in the middle here, I got an answer that was slightly off here, 0.0617, which is off by, 12 thousandths of a millimeter, which is pretty small. But I just wanted to give you that option. Anyway, for question number 8, the numbers were cut off, so you couldn't have done it. Isn't that fun? All right, take a look at the problem set for lesson 7. Here's where we started to talk about the law of cosines. Now you can actually use that shortcut that I showed you. So pause the video, try it out, and then come back to see if you got the right answers. All we had to do for these problems was to apply the law of cosines. We applied the law of cosines every single time using these two adjacent sides to this angle. And we were able to find it fairly easily by plugging into our calculator. As an added bonus, all of these answers was 7. How lucky. For question number 4, it was a little bit of a reversal. You had to reverse the process. You had to substitute all the numbers in except for the angle, which in this case was angle C, and then solve backwards. A quick note, once we got 0.6 equals cosine of c, you know that the inverse of cosine is cosine -1. We call that the inverse cosine, sometimes known as the arc cosine. Anyway, you should have applied that to find the measure of angle c. Question number 5 was very similar to a question that we did previously. With the largest angle, you find the largest side. It's across from the largest angle, which means all we have to do is substitute into the law of cosines and then inverse cosine to get the angle. Take a look at the next page, pause the video, and see what you can do with it. And then check your answers. Did this page feel like a greatest hits compilation? It should have, because this question and this question you already did. For question number 8, you needed to reach back into your toolkit of proportionality and looking at related rates. You learned about this several grades ago. First, we found out how long County Route 21 was. We used the law of cosines to find 63.117 miles. Then we did two proportions. If we traveled at 55 miles an hour, 55 miles an hour, how long would it take us to travel 63.1177 miles? And if we traveled at 65 miles an hour, how long would it take us to travel 65 miles? 1 hour. So the difference between these two times is 0.1476. If you multiply this by 60, you get about 9 minutes. I think it's 8.8 minutes. And then question number 9, we use the law of cosines again to find 181. That's the distance between A and B. And we can use the law of sines to find the measure of the angle that is here at angle B. Keep in mind, we used 75 in our calculations because 75 is across from angle B. That's where the 75 comes from. All right, moving on, please take a look at the next problem set, pause the video, and then unpause it when you're done. Now for lesson 8, you didn't really have a problem set, you more like had partner practice. So I just wanted to show you the answers to the partner practice briefly. In this one, it was another case of the measure of the largest angle. The largest angle is opposite the longest side. So if I know that this side is 30, whatever angle this is has to be the largest angle. The law of cosines makes short work of this problem. Keep in mind here we used the Greek letter theta for a variable. Theta is usually used for a missing angle. For the next problem, it was another classic two triangles question. We set up two tangents. Remember, we're generally always going to be using tangents. We set them equal to each other. We solve for one side, and then we use that one side to find the other side. Not a big problem. There are two more partner practice problems that I'd like you to make sure that you got right. Pause the video, try it out, and then see if you got them right. All right, for these word problems, always very important to draw a diagram. Once you draw this diagram, the searchlight sweeps between A and B. 12 and 25 are our distances, and 29 is our opposite distance. Then you can see that we're going to use the cosine law. That should be the answer there. And then for the partner practice, here's a sneak preview of areas. It asks you to find the area of this green triangle, which is here. Then we need to find the area of this purple triangle that's up here. In order to do that, we needed to find this length, which of course is 6. We use the Pythagorean theorem. Once we found these two areas, then we added them together. It should make sense that the area of this green triangle plus the area of this purple triangle is the area of the entire preserve, the area of the entire forest. All right, last but not least, the problem set from lesson 9. Pause the video, try these out, and then see if you got them right. Lesson 9 started off with area formula, which of course is 1 or 2, not 3 or 4. 123 was placed correctly here because it is an angle, so it's choice 1. Here we use the area formula again, 78. We use the area formula again, 8.6. And then another area formula to get 181.4. Then for here we did the area formula and we had to do a slight amount of backwards solving because we had sine of A. We needed to get rid of sine. So we got choice 2. All right, last page of the last problem set. We're almost there. Do this, check your work as soon as you're done. For this problem, you needed a diagram. We drew the diagram, DOG, that's dog. We found out the angle using triangle sum theorem. We used the law of sines to find the missing side, and then used the area formula. Something very similar happened in question number 7. We used triangle sum theorem, law of sines, then area formula. Question 8 just required you to know what a parallelogram was, which means it's finding the area of one triangle and multiplying it by 2. Question number 9 gave us a very straightforward question about finding the included angle by using inverse sine. And then question 10, it asked us to find the two different areas. All right, that was a review of unit number 8. Good luck studying.